Welcome back to the deep dive. Today we're looking at a stack of material on something small, incredibly rugged, and just amazingly loud.
Yeah,
The NTI E-BEEP1-800 Rugged Miniature Piezo Alarm.
that's right. And our mission here is to figure out what engineering tricks they use to build this tiny screamer and, why those very specific technical specs actually matter.
Exactly. I mean, when you see rugged and miniature right next to each other, that's already a bit of a contradiction in engineering, isn't it?
It is. We have a device that's barely over an inch across, but it's designed to blast out up to 103 decibels. That's really the core nugget here, this massive output from such a minimal footprint.
Okay, let's unpack that sheer auditory punch. The specs say 95 to 103 dBs at just 2 feet. I mean, just to put that in perspective for you, that's louder than a lawnmower. It's getting into jackhammer territory. This is not a gentle beep.
No, absolutely not. It's made to cut through heavy industrial noise or, really alert personnel immediately.
And what's wild is how little power it takes to generate that kind of volume.
That's the fascinating part. It runs on anything from 5 to 15 volts DC, and it only sips about 50 milliamps at 12 volts. It's designed to just plug into existing NTI monitoring units like their E2D or 5D systems.
So it's a low-power add-on, but with a really high-impact result.
Exactly.
So that brings us to the big question. How does something so small scream so loud and still survive, being thrown into some really hostile environments? What exactly makes this thing rugged?
Well, it's really built for survival. The first thing is the internal components are completely encased. It's what's called epoxy encapsulated.
Okay, so it's basically a solid block inside.
Pretty much.
Yeah.
That gives it polarity protection, sure, but the key thing is it makes it fundamentally resistant to vibration and shock. There are no moving parts to fail.
Right, so it can't rattle itself to pieces. But the source material also lists some very specific protection ratings that go way beyond just being in a solid case.
Oh, they absolutely do. This is where it gets serious. It's rated at IP68 and ASTM B117.
IP68, I think most people know, that's total protection against dust and water.
Yeah, total. You can completely submerge this thing and it will still work.
So is it designed for, I don't know, being buried underground? Or maybe surviving in a constantly damp crawl space?
Both of those. But the ASTM B117 rating is the real clue here. That's a standard for accelerated salt spray testing.
Ah, so corrosion resistance.
Exactly. It confirms this device won't corrode in harsh, salty air. Think marine applications, coastal infrastructure, even chemical facilities. And then there's the temperature range.
Oh, this is the one that really got me.
It operates reliably from -4 all the way up to 149 degrees Fahrenheit.
Wait, so you're saying from a frozen utility pole in Alaska to an unventilated equipment shed in the Arizona desert, it just works?
It covers that entire 153-degree thermal swing.
Yes.
That kind of flexibility is huge for anyone designing a system.
And speaking of systems, the material also mentions some logistical things. TAA compliance, UL, ROHS approvals.
Right. And for those who might not know, TAA compliance means it can be purchased by U.S. government agencies. It meets certain manufacturing and quality standards.
So that really speaks to its use in secure critical infrastructure, doesn't it?
It does. But despite all that, the installation is dead simple. It's a 2-wire interface, it's panel mountable. But the key insight for deployment is the cable length.
1,000 feet. I had to read that twice. 1,000 feet between the monitoring unit and the alarm itself.
1,000 feet, or 304.8 meters. It's incredible. It confirms this is meant for huge, decentralized sites. Think about stretching a security perimeter across a whole campus or a massive industrial park.
Yeah, you could put the sensor hub in one building and the alarm in a completely different one, way across the lot.
Precisely. And they offer cables all the way from 1 foot up to that 1,000-foot maximum. The flexibility is just built in.
So wrapping this up, what have we got? A tiny device that delivers a massive alert, can survive extreme corrosive conditions, and stays connected over huge distances. All for $265 with a 15-day trial.
It's a perfect example of purpose-built engineering. And that really brings up a final thought for you to consider. Given these specific protections, the IP68, the salt spray testing, that immense temperature tolerance, what kind of hidden environments demand this level of engineering? Thinking about that helps you understand the invisible infrastructure, the data centers, the remote pipelines, all the silent but ready systems that keep our world running in places you'll probably never get to see.